People did not take radium by accident. They paid for it, they lined up for it. They drank it every single morning. The way you'd take a vitamin today, with hope, with trust, with the quiet belief that science had finally handed them something miraculous. Radium toothpaste, radium water tonics, radium chocolate. These were real products, sold in pharmacies, advertised in newspapers. And the scientists who discovered radium, we thought we were giving the world a gift. I did not warn anyone. I want you to understand that. Not because I was careless, but because I genuinely did not know there was anything to warn about. That is the part that should stop you. Not the products, not the marketing. The fact that the people closest to it, the ones who found it, named it, held it in their hands, had no idea. How does something feel miraculous and be killing you at the same time? That is the question I want to think through with you today. And the answer is more unsettling than you might expect. Let me start with where it actually began, not in some gleaming laboratory, with polished floors and proper equipment. In a shed, a leaking, unheated shed on the Rue Vauquelin in Paris. Pierre and I worked there for years. The ceiling let in rain. In winter we could see our breath. We had almost nothing. No funding. Barely any staff. Just the two of us and a mountain of pitch-blende ore. We'd convinced someone to ship us from Bohemia. We were looking for something in the uranium ore that we couldn't account for. A source of energy that didn't match anything we understood. We processed tons of raw material. We boiled it, dissolved it, filtered it, precipitated it down again and again and again. And slowly something emerged. Something new. The night we first saw it glow. I remember standing in the dark of that shed, and the little dishes of concentrated material were lit from within, not reflecting light, making it a faint blue-green luminescence, coming from something we had just pulled out of rock. Pierre and I stood there in silence. You don't speak at a moment like that. There are no words ready. What we had found, what was causing that glow, was radioactivity. Atoms that were unstable. Atoms that couldn't hold themselves together, so they released energy in the process of falling apart. That energy came out as radiation, particles and waves, fired outward from the nucleus at extraordinary speed. We named it, we measured it, we isolated two new elements, polonium and radium. And I want to be careful here because there is a distinction that matters enormously. We named radioactivity. That is not the same as understanding it. We knew radium was doing something to the matter around it. We watched it fog photographic plates through solid containers. We felt warmth radiating from a sample left on a bench. We knew it was powerful. What we did not know, what no one knew, was what it was doing to us. Now here is where the world gets involved. And to understand why everyone decided radium was medicine, you have to remember what the world felt like in 1900. Electricity was less than a generation old. X-rays had just been discovered, and people were stunned by them. Genuinely stunned that you could see through human flesh. Energy itself felt like the frontier of healing. If invisible forces could illuminate bones, what else could they do? And then radium appeared. It gave off heat without any flame. It glowed without any fire. It released energy continuously, day after day, with no apparent fuel source. To people at the time, it seemed almost alive. It seemed like the most vital thing on earth. And here's the thing. The early medical results weren't wrong. Not entirely. Doctors began using radiation on tumors, and tumors did shrink. That part was real. Radiation kills fast-growing cells. That's the basis of radiation therapy that we still use today. So the science had a genuine foothold in medicine. The mistake, the fatal, logical-sounding mistake, was the next step, the leap that went, if radiation kills sick cells, then it must energize healthy ones. If it destroys what is diseased, then it must strengthen what is well. It's almost a beautiful piece of reasoning. Symmetrical, clean, completely wrong. The logic felt sound. That is the most dangerous kind of mistake, the one that feels like it should be right. So radium went into the water, into the toothpaste, into the cosmetics. Eben Byers, an American socialite and amateur golf champion, drank a bottle of radium water called Radithor every day for years. He believed it gave him energy. He recommended it to friends. The Wall Street Journal eventually ran his obituary under the headline, "The radium water worked fine until his jaw fell off." That was not an exaggeration. His skull had partially dissolved. His bones had holes in them. He weighed under 100 pounds when he died. What happened to him? What was happening to everyone who ingested radium is a chemistry problem, a very specific one. Radium sits in the same column of the periodic table as calcium, same group, similar atomic behavior, and your body is not sophisticated enough to tell the difference. When radium enters the bloodstream, your body treats it exactly like calcium. It pulls it into the bone matrix. It deposits it deep into the skeleton, where calcium belongs, and there it stays, permanently. Radium in bone does not leave. It has a half-life of 1,600 years, on a human time scale. Once it's in, it's in. Now it's firing radiation from the inside. Not a single dose from an external source. A continuous, unrelenting emission of alpha particles right there inside the bone. And alpha particles, which we sometimes dismiss, because they can't penetrate skin from the outside at close range, inside tissue. They are devastating. They tear through DNA. They shatter the molecular machinery of cells. Over months and years, they destroy the bone marrow, the surrounding tissue, and eventually the cells begin to do something terrible. They start to multiply uncontrollably. Cancer, from the inside out. The Radium Girls knew this firsthand. They were young women who worked in factories, painting watch dials with radium paint so the numbers would glow in the dark. Their supervisors told them to point their brushes with their lips. Lip dip paint, lip dip paint. They ingested radium every single working day. Some of them began to glow, their breath visible in the dark. Their bones were saturated, jaws collapsed, teeth fell out, spines fractured spontaneously. Some of them died in their 20s. And my own hands, I should tell you about my hands. My fingertips were destroyed, the skin chronically damaged from years of handling radioactive material. I developed cataracts. My bone marrow failed. I was diagnosed with aplastic anemia, which is what happens when radiation has spent years dismantling the cells in your marrow that produce blood. My notebooks from that period are still radioactive today. They're stored in lead-lined boxes in Paris. If you want to read them, you sign a waiver, because the pages themselves are dangerous. My body kept the record that my notebooks could not. But here's what I need you to understand. And this is the part that nobody talks about, the part that feels almost impossible to sit with. None of us were hiding anything. Nobody was lying. The harm was real, but the harm was slow, and slow is invisible. Radiation sickness doesn't arrive like a burn. It doesn't announce itself. It comes the way old age comes, gradually, ambiguously, deniably, a little fatigue, some joint pain, a slow decline that could be anything. Years pass, a decade, sometimes more. The body is breaking down, but the breakdown looks ordinary. This is called latency, and it's the cruelest feature of radiation exposure. The gap between cause and consequence is so long that the human mind simply cannot connect them. You drink radium water in 1910. You feel fine in 1912. You feel fine in 1915. By 1920, something is wrong, but by then, who remembers the water? Who connects the dots across 10 years of ordinary life? In that gap, everything continued. Careers were built, products were sold, companies made fortunes, workers were hired and exposed, Nobel Prizes were awarded. I accepted 2 of them, working with hands that were already being damaged by what I was studying. Nobody was reckless. We were early, and being early meant there was no one to learn from except ourselves, except our own bodies, except the slow accumulation of sick people that eventually became too large to ignore. And even then, even now, the story isn't finished. Here is what we still don't fully understand. Why does one person exposed to high levels of radiation develop cancer, and another doesn't? We know that cells have DNA repair mechanisms. We know these vary between individuals. Some people's cells are better at catching the damage and fixing it before it propagates into something malignant. But the full map of individual susceptibility, why some bodies are more resistant, what genetic factors govern that resistance, we are still drawing it. It's incomplete, and the question of low-dose radiation is genuinely contested in science right now. There's a model called the linear no-threshold model, LNT, which says that any amount of radiation, however small, carries some proportional cancer risk. No safe dose, no floor, but there are serious researchers who challenge this, who argue that the body can handle small doses, repair the damage, perhaps even adapt. The debate is real. The answer isn't settled. Meanwhile, radon gas, a radioactive decay product that seeps naturally from soil and rock into buildings, is the second leading cause of lung cancer in the United States. Not a distant exotic risk. In basements and ground floors, right now, in ordinary American homes. Most people have never tested for it. Most people don't think about it at all. We know more than we did. We do not know enough. So what does all of this mean? I've thought about this for longer than I want to admit. Not just as a scientist, but as someone who lived inside this exact blind spot. I breathed the dust from processing pitch blind. I warmed my hands near concentrated radium on cold nights in that shed. I carried test tubes in my coat pockets. I am not speaking to you from a safe distance. I am speaking to you from inside the mistake. And what I've come to believe is this. The lesson is not that science was wrong. Science wasn't wrong. It was incomplete. Incomplete in a way that took time to reveal. The lesson is that the gap between discovery and understanding is where people get hurt. Every single time. Not because of malice, not because of carelessness, because the gap is real, and it takes years to close, and people are living in it the whole time. Every era has its radium, something glowing, something promising, something powerful enough to seem like the answer before anyone has had time to ask the right questions. I won't pretend I know what yours is, but I am certain it exists. Something that feels miraculous right now, that the smartest people in the room are certain about, that everyone is rushing toward, and that someday someone will look back on and wonder why it took so long to see clearly. I would do it again. I want to say that plainly. The work mattered. Polonium, radium, radioactivity. The understanding we built, and that others built on, has saved millions of lives through cancer treatment and medical imaging. I do not regret the discovery, but I would have held the uncertainty more carefully. I would have said out loud, more often, here is what we know, and here is what we don't. I would have told people what I didn't know, not only what I did. My notebooks are still in Paris, still sealed in lead boxes, still glowing, quietly after more than a century. Beautiful objects, dangerous objects, both things at once, completely without contradiction. That is not a metaphor. That is just what discovery looks like from the inside.